Hello everyone. Well, today we're going to take a look at linked int list. Okay, so you may remember from my previous video that we talked about the list node. Okay, so we have this list node here, right here on this side over here. And basically what we did here is we took these list nodes. So here's a list node that had some data in it, 37 here. And then what happened here is we created another list node here, and we put 42 in it here. And then basically, when we reached the end of the list node, it had a null there. Okay, so what we're going to do actually now is we're going to encapsulate this here. We're going to actually put it into a class here, and it's going to be actually called our linked int list class, so which I have right here. Okay. And so, of course, it's going to support several different methods here. We'll walk through them. The first one that we'll use is the add, because we want to add values to the list. And then, of course, we want to print our list here. And we want to remove the list. And then when we finish, we want to actually clear the list here. Okay. So let's go ahead and take a look at a run of this here. So clear the screen draw here. Oh, and actually before that, let's take a look at the UML diagram for this, okay? So basically what happened, here's linked int list, which is uses the list node. Okay, so here's our list node class, which has our data field, and then it has the link to the reference actually to our next list node that allows us to chain these together. And this is our class that encapsulates all these list nodes together. So basically what happens, it has the front node, okay? And so that's how we basically track all this here. Whoop, it looks like we have, and it looks like let's turn that off there. Let's go back to the screen draw here again. And we'll use this one here. So the field here, this is the important thing here. It's like the beginning of it all, and everything is chained after that, okay? And of course we have our constructor here, and the constructor is just going to initialize a new list node. And you can imagine when we want to add list nodes to it, it's just like when we looked at the list nodes individually, but what happens is this container class is going to say, oh, if there's no nodes in there, it's going to create a head node, okay? Now, if there are already nodes in there, it's going to walk down the list, the chain basically, and it's going to add it to the end, okay? So let's go ahead and take a look at these methods here. But first, before we do that, let's take a look at a run. I actually have a tester class here, which often when I'm doing development, or I'm always doing development, I create a tester class, okay? And let's go fire up the debugger here. This is in JGrasp, okay? And so we launch the debugger, okay, and it starts here. And let's see, it looks like it has started, and I'm looking for my variables here, and for some reason I do not see, let's see what happened, in debug here. Oh, I think I know what happened. Let's see, let's go back here. Oh, okay, it is actually working here. Yeah, there we go. It looks like I just took a moment to get there. You can see the debugger is actually stopped right here. Let's get our viewing canvas here. So in case you haven't used the viewing canvas, let's just annotate that there. So right this little, like right there, that button right there, open new or existing viewing canvas. So let's go ahead and clear our drawing on the screen there, get it open, and we'll get a new canvas here, and let's drag it over here so you can see. And okay, and then what we're going to do is actually, now when we see we have our new list here, what happens here is it actually has that front node. So I'm going to pull it out here of my list there, and now you can see here, this is like our linked list here. And now when I go ahead and I add in a node, it's now got list node 13 at the beginning, okay? And before we were using this like next, next, then data, and then next, next, next data, okay? Now we're just saying like, oh, add it to the list, and it's going to actually link it in. You can see it's like completing the link for us there. It added it to the end of the list there. And so you can see here the 6 is at the end. Now it's going to add the 744, add the 99 there. Okay, And now take a look here at the bottom. Here it's going to print out the list. So you can imagine it has to walk through all the links going through the next, next, and next. Okay, now here's an interesting one. What's going to happen here, it's going to actually delete this first node here. When you look at this here, this 13 here, we're gonna delete that. Okay, so now this is front. When you see this here, all we have to do is inside of the delete. If we're deleting the first node, all we have to say is front equals front dot next. Okay, so let's go ahead and clear that there, and we'll hit the next on the debugger here, and voila, there we go. We see that that 13 got deleted there. Now we're looking at list remove item number, let's see, number 3. Okay, so these are all 0 based here. So we have 0, that's the first element there. We have 1, we have 2, and we have 3. Okay, so now we can see right here when it says remove item number 3, it's going to delete that 3. So let's go ahead and click the next on it, and sure enough, the 744 gets deleted there. The 19 moves to the next there. And finally, the last method we're going to introduce on this here is the clear. And as you can imagine, it's going to set the list to null. And so, or it actually sets that front node to null. And boom, everything, because there's nothing tied to it, there's no references to any of these nodes here, they just like sort of fall to the ground. And they go away. The garbage collector collects them. And there we go. Voila, we're at the end of our test driver here. And so let's go ahead and close our viewing canvas here, and let's see how to add these methods into our linked int list. Okay, so we'll hit save and close on our debugging session here. Let's hit end on it here. And now let's go into our linked int list, and I'm just going to take out these methods here. So we have on our control structure diagram here. And so we'll take out all these fancy methods and we'll add them in manually so that you can see this here. And of course, the first method you see here is we have the constructor. Okay, and all the constructor is going to do is actually set that list node front to null. You know, we create a linked int list. You know, it's basically saying I have a linked int list ready for you to add nodes. There's no nodes in there. Okay, so let's go ahead and add in the method here. Okay, so it's going to be public. All right, it's going to be void. There's no return type on this here. And we're going to say add, and then we're going to say here it's going to be int, and then we're going to have the value. Okay, so the value to add there. And now we said that we had this special case here. It was like, oh, if the front is null, so basically here it says, well, first of all, we have to create a new list node. Okay, new node equals new list node. Okay, and then we're going to say that the new node dot data. Okay, so you can see on the right there equals the value. All right, and then we're going to say list node current. Okay, so what happens? This is actually going to be what, like a reference that tracks it. It's going to walk down the list to find. Okay, so if excuse me, front equals null. Okay, this is our empty list here. All right, and then we say that here new node. Oh, let's see here. Actually, here we just say front equals new node, and we're done. So front equals new node, voila, and that finishes that there. So that's our special case there. It usually happens when you when you have an empty list, you have a special case here. But if it's not empty, then what we have to do is we actually have to say, okay, let's go ahead and let's traverse the list. So current equals front, okay. And then we're going to say here while current dot next is not equal to null, and this is where it actually is going to walk down the list here. It's going to say current equals current dot next. And that's sort of strange. You may say like, well, why is it we say current equals current dot next? And you're going to grab that next chain until you reach that last chain there. And then what happens once we reach that there, and then we say current dot next equals new node. Okay. And let's go ahead and put that semicolon on that there. Let's put in our closing curly brace there. And we got that there. Let's hit save. Let's turn on our control structure diagram there. You can see our loop right there. This is our if then else statement for our special case on the front there. Our new node at the top there. And let's go back to our tester here. Okay, so basically it happens now. We're just going to comment out these items here. We're going to hit save. We're going to hit the debug on this here. And let's watch how it goes through and actually adds in all these here. So we open up our drawing canvas here, the same one that we had last time here. And now what we'll do is we're going to actually step into it. Okay, so now you can see my front list is null. The front's null. We step in. Okay, so it's going to create this new list node. So you can see that right there. We have our new node right there. Okay, so there's new node. Now let's step down and say list node current. And it looks like that's our local variable there. And so we have the data there is 13. Okay, and now what happens here is you're going to watch this next step here. It's going to actually change the front to the new node. Voila, there we go. We can see that now it has done that there, and now our front is now that node. Okay, and so we can actually let's just remove this from this here. So we've added that first node. Now this one here, when we add the 42 in, okay, now you're going to watch it here, and you're going to see actually that it goes through, and it's going to fall into this case right here. Okay, and what happens, the current's going to have to go here, and then right here, this goes to, that's the null right there. Okay, null. Okay, so it's actually terminating there, and this is where the new node's going to go. Okay, so new node goes right there, and you're going to see, oh, and it looks like that's the edge of our screen there. Well, let's just walk through this here. You can see here on the left. Let's step through it. Okay, and here's our new node. Ooh, look at that, the new node value 42. It doesn't match this first case here because our new node is not null, so it's going to walk into there. And now watch this current pointer here. Now it's going to traverse the linked list because everything is just linked. It's just links that follow through. And now it happens, it says, oh, okay, we actually hit the end because the next is now null. All right, and now it happens, it puts in that 42. Excellent. Okay, so let's look at it one more, the 15 here. Okay, we're going to step into this here. Okay, and now what we're going to do, ooh, let's move this over a little bit so you can see. Here's a little step in button right there. It's also, actually, let's go right here. So in case you missed that step in, let's take a look at it. It's right here. So when you want to like see, ooh, it looks like we got a drawing here. Let's see, I thought I said, yeah, there we go. There's a step in right there. Okay, so when you want to step into the method, you just click on that there. And now we're going to step, this is going to walk the lines because we're on line number 2. We're already in the method that we want to see in particular. And now we can see here's our new node. We put in the data 15. It's like, oh, now where does it go in the list? So now we have to go in the else method here. We got current. It's going to track it. You're going to see current go to the 42 there. Now the current.next is null, and now it's going to say current.next new node is equal to new node there, and it puts it in there. So you can see, you know, our add is working here. It's adding nodes to the end of the list. So all looks well. Okay, so let's just hit stop on this here. We've added all this in here. And now let's go back here. Let's close this our viewing editor here. We're going to go ahead and we're going to actually take a look now at print. Okay, so let's uncomment all our lines here. We'll get a few extra lines in there to see this here. So we'll just add in all these extra elements here. And now on the linked list, we're going to go back in. We're going to add in our next one. So just fold that one right there. And so on print, it's going to be a public method. Okay, it's not going to return anything, so it's going to be void print. Okay, now you may be wondering, what do we pass to this here? Okay, Now remember, we're doing object-oriented programming. This is a linked int list that contains the head node. This is what confuses a lot of students. They like go, well, what do I pass into here? Well, it's because you got this object of this linked int list. You don't pass it anything. It's actually already here at the top. Okay, there's our head node right there. It's like our sort of global variable, but it's our variable that belongs to our object. So it's in the scope of our object, and I'm sure some people will object to me saying global variable because it's actually it's a class variable. Okay. So and this is one that's relatively straightforward here. We're just going to say here we're going to once again we got this theme that goes current. Okay, and currents is like walking down the chain. Okay, it's like pulling it up. You don't know when you get to the end. You just have to keep on pulling the next list node. So now we're going to say list node current equals front. Okay, and here you can see while current is not equal to null. Last time we looked at current.next because we wanted to stop before we reach the end here. Now we're like looking at like, oh, we want to look at nodes that as long as we don't reach the end. So you just have to sort of, this is one of those good things to run it through the debugger and check and see. Okay, and now we know that the current node is not null, so it should have data. So we just say system.out.print, and then we're saying current.data, and then we'll add a space in there. Okay, so we got a space in there, we get semicolon in there. Okay, and then after we're done with printing all the lines here, we're going to say system.out.println. Okay. And so let's go ahead, let's turn on our control structure diagram on this one so you can see here. It looks like we have a bit of an error here. Let's see, expecting member declaration here. At the let's see here, I forgot to put in a curly brace here on the while loop. Let's take out actually this curly brace here. I did an opening. We only have one statement on that there. So turn on the control structure diagram. You can see here's our loop right here. Oh, it's not going to fold in actually. Let's see here. Let's try to fold it right there. So hit F4. Okay, so it unfolds it there. So you can see right here that the current, and let's just walk through this here. Let's go back to our tester here. Here we have our print method, and now we're going to launch the debugger. Okay, wait for the debugger to start. The debugger starts, and now let's take out our breakpoint here, and now let's put in a breakpoint right there on line number 12. And let's advance. Oh, and let's open up our viewing canvas here. So we have this viewing canvas we already created here. You can see here's our list node front, and now what we're going to do is this fast forward thing. Okay, so you can see that the debugger is actually on line number 5. Okay, so right here the debugger's right there. We want it to stop right there, and then what happens? We want to hit that, that step into on the print method there. And then we're going to watch this current here, actually go down all the nodes. So you're going to see all the nodes here like this. Oop, we're going to have arrows to them, arrow, arrow, and then it's going to continue for all these nodes that we have right here. Okay, so let's go ahead and clear that there. Fast forward, and then we'll step into, watch this thing. There we go, voila. You can see we have 13, 42, 15, 6, 7, 44, 19. Matches all the numbers we have over here. We're going to hit the step into the right, that arrow there. And here you go. You can see now that this is the magic here where it goes the current. There we go. You can see current points to 13. It's another reference that points to it. And now what we're going to do is every time current's not null, we just print it out. And now you should see that it prints out the output right there. So let's take a look here. Just watch here. Let's just, in case you're, whoop, we get screen drawn here. Why is it not working? There we go. Yeah, it's like I used a different marker here. And there's a 13 there. We're going to watch this as it prints out all those elements there. Okay, so step down. You can see current's going to step through. And and what happened there? We made a mistake. Current does not advance. So we actually said here current equals not equals null, and current stays on the head node here. So let's go back and fix that there. Okay. So we're going to go to this here. We're going to put in our curly brace here. Then we're going to go here And so our program was incorrect. And now what we're going to say here is current equals current dot next. And this is like the secret sauce that walks down the list. Now we got this here. We can see it's in our loop there. Let's go ahead and go back to our tester here. Let's hit the debug again here. Okay, and there's our list. And now we're going to do our step into. And voila, here you can see the current. And now let's take a look here. Let's watch down at the output here in the bottom portion of the screen. I won't circle it this time. Okay, and you can see there's a 13. And let's see, did it go to current.next? It did not because I didn't compile. Let's hit stop here. And let's go back to linked and list and hit compile. I thought it would have compiled automatically. And now we'll rerun the debugger here. This is like, okay, here we go. And let's see here, we're going to step in. Okay, let's see here. Now it should actually go through. Current, it prints out the 13. Current goes, there we go. You can see now it actually jumped to the 42. And now it's going through the 15. You can see the 15 printed out. Now it's going to jump to the 6. You know, outputs the data. 744, 19. We're golden. And there we go. It's null now. At the end of the 19, there, that little box that you, oh, maybe you can't see that there. Let's just annotate this right here. Okay, so you can see this here, that there is pointing to a, oh, it looks like I reached the edge. Let's scoot it over to the left here. Oop, it's a null. It's pointing to a null. I'm not going to correct that one there. Okay, so 19 is where it ends. It ends at a null there. And so we're good to go. So let's hit stop on this here, and let's add our next method in here. Okay, and let's code fold this here. This is our print method now. We already hit end on the debug. Okay, and let's go back in and do the next method. Okay, so the next method is going to be remove. Okay, now remove is sort of interesting because we have to stop before the node that we want to delete. Okay, so public, okay, void, it's not returning anything. Okay, now remove, okay, and this one, the argument's going to be the index that we want to remove. Okay, so index here. And then, of course, we're going to have this here. So we're going to have a special case here. So it's going to be if the index is equal to 0. Okay. Then what happens here, we have a really easy case here. It's just like front equals front dot next. Okay, just like says, oh, just make the front point to the next node there. And because of Java's garbage collection, it just goes away. It's just like you cut the thread from it there, that front node just like dropped to the ground. And then the garbage collector came and swept it up. Okay, but now this is the interesting case here. We have the other case where we do have to go through and we have to find out where that index occurs. Okay, now the precondition is on this that we do have actually adequate number of nodes in this here, that the index does exist within the number of nodes that are on this linked and list. Okay, so I did not throw an exception on this here, but we're assuming that it actually has. Okay, so ListNode, so we're going to do our current here, and it's going to be current, and it's equal to the front. Once again, our front is our member variable, data member for our linked and list. Okay, and so now what we're going to do is say, let's see, so for, and then int I equals 0. Okay, and then to I, then I is less than index -1, because we want to stop before the node that we want to delete, just by the nature of this linked int list here. Now we're going to say current equals current dot next. There we go. That'll stop us right there. And So we reach that there. That's going to do our loop there. And now this is where the key magic happens. Okay. Now if you need to watch the other video I did on the list node here for removing a node in the middle, and we just do this little fancy magic here. We say current next. So we want to point where it is that we stop. And then what happens? We're going to say to skip over. We're going to say that next is now the current dot next. So we're going to sign it here. Dot next. And this is like where, if you watch my previous video, you see that, you know, traversing these nodes and referencing them. And let's take a look here and see. Okay, so we got that there. And let's check and see here. Let's turn on our control structure diagram. It looks like it all works there. We have our if statement here, our else here, our current list node reference here, the loop. And let's go back to our tester here. And so we have our two cases here. We have a case where we're going to test the first node, and then we're going to test the third node. Well, it's actually node number 3, which is really a fourth node because it's a zero-based indexed as far as the first node goes. Okay, so let's delete our point there. Let's go put a breakpoint on that there. We're going to start up the debugger. Okay, debugger's launching here. Oh, and it looks like we have, let's hit stop here. I think I saw an error or something like that. I need to compile actually this here. Let's make sure that, okay. Oh, and it says here, I made the all ubiquitous error here, and cannot be converted to a Boolean here. Thank you, Java, for doing this here. We should have a double equal sign in there for comparison, not using assignment there. Okay, so let's go back here and go back to our tester now. So now we're on our tester. We're launching the debugger. Let's go ahead and pull up our viewing canvas here. So we're going to use our same viewing canvas that we used the previous time. And once again, we're going to use the step into. Okay, so right here, and there's two different ways you can do the step in. You can also step in from here. Once we step in, now you can see here. Now this is the unique case where it's index number 0, so it's going to delete this 13 node. And now you can see here the front equals front next. That 13 is just going to disappear, and then the 42 is going to move over there. Okay, and that's done. Okay, so now here's the interesting one. Is the second one. It's going to be the fourth node, which is really index number 3 here. So let's go ahead and take a look at it. So this is number 0, number 1, number 2, and then number 3. Okay, so what happens here is we need to take this 6 and make it jump over to the 19 there. Okay, and so so now what happens is that you're going to see that's going to be the next. Okay, so let's go ahead and clear this, and we're going to watch. We're going to do the step into. Okay, and now you can see the first case on the if is not true, and this is where it does the current. Okay, so it should stop right here on the 6 because we're deleting the 744. Okay, so there we go. Okay, it stopped. Okay, and this is where the magic happens, where the current next is equal to current next. It's actually an assignment. So, and there we go. It deleted that 744. Voila, we're magic. We're good. Golden. Okay, so we're golden on that there. And let's go back and implement our final method on this one here. It's the clear. We're going back into the linked and list. And let's fold this one back up here and go into this here and public void. Let's not return anything here. And we're going to say clear the list here. Okay. There's no argument passed to it. Okay, on the parameter list. And this one is super simple. But this illustrates how that what happens is that in Java, it's like once you have no reference linking to it, then the objects just fall away. Okay, so all these list nodes that are here, we're just going to say the front, our member variable that we can see that's right up here, right there. We're going to just say it's equal to null, and then what happens? It like cuts the chain, cuts the I call it like sort of the thread that's tied to it there, and now it deletes all of our lists there. Okay, so let's go back and check this on our tester here. Let's first of all compile it here. We have to end our previous debug session here. Now let's check the tester. Okay, let's take out our breakpoint here. Let's uncomment the clear there. Okay, and you can see here we're going to hit the breakpoint on this. Oh, and let's see here. Oh, clear. Oh, cannot find the symbol because I didn't add it. Let's go back in here. Compile our code. Forgot to compile. All right. Go back into the tester. Now hit the debug symbol there. Alright, the debug says still cannot clear. Did I misspell clear? Let's go back into this here and see clear. Oh, we said clean. Well, that was sort of interesting. Alright, so we misspelled the method there. Let's go compile it again. Clear. Alright, let's launch the debugger again. Interesting error there. The debugger is happy now. Let's check out our, once again, our viewing canvas here. Okay, and we're going to use the same one that we did tester 2 here. We can reuse that there. Open it up there, and we're going to use, once again, we're going to step into this here. So we're going to hit that right downward arrow, downward to the right, and it steps in. And watch this here, just in one swoop here, it just clears out the LinkedIn list. So it's empty now. Okay, and this is just like when we started. When we constructed our list, we created it null, so we came back in full circle on this one here. So you notice all our methods here have void return types. Now, of course, if you're saying get, you're going to say get a node, then you're going to return like an int return type. Okay, well that's our class here, a linked int list here for encapsulating this list node. So you can see right here, this is our member variable right here. In fact, our list node, and that is actually, just to summarize here, go back in there, and that's actually what our member is here. That's our key point here. It's just managing this here. So just to reiterate this, what this whole thing is doing here is managing this list node because it's all chained together, and these methods here are so that you don't have to say next, next, next. It just says, okay, I'm going to use this magic current reference that finds out where I need to go and do what I need to do. All right, well, thank you.